because that was not. Susie, and try to pay attention to this. Susie is organizing the printing of tickets for a show. Which company is going to be better to order tickets from? Does it matter if they sell 10 tickets or 1,000 tickets? For how many tickets would it be better if both, for how many tickets would it be if both companies cost exactly the same? How many tickets would you get, I guess, if both companies cost the same? Okay? Yeah.
The wording on ours is way different.
Really? Way, way different? It is about tickets, though.
Yeah.
So basically, okay. Basically, it's probably the same scenario, but maybe it is not word for word. So let me see what yours says. Printing show, she has collected prices from several printers. These two seem to be the best. Susie wants to go for the best buy. She doesn't yet know how many people are going to come. Show Susie a couple of ways in which she could make the right decision, whatever the number. Illustrate your advice with a couple of examples. Okay. So, I am going to, Andrew, give you, I'm going to say 3 minutes to start to come up with any kind of idea of how to answer these questions. Which company is going to be the better one to order tickets from? If we want tickets, what are we usually looking for when you order something? If you're comparing two stores and two different things, what are we looking for? Price. We want high price, right? No, we want low price. We want it to cost as little as possible, right? If the quality is the same. Does it matter if we sell 10 tickets or 1,000? Maybe. How could we find out? And how many tickets would it be if when both companies cost exactly the same? So I said 3 minutes. I'm going to give you 5. I'm going to let you stew a little bit more. Anyone? Nothing? We got nothing. Okay, well, let's see. Anybody have a suggestion of how to even get started? Yeah. It says plus in best print. And what does that mean? Adding the numbers together. Okay, what numbers are you talking about? Help me out. I'm not sure what you mean. 10 and 1? So like this 10 and this 1? Is that what you're talking about? What do you guys think about that? So if it's a $10 setup fee plus $1 for 25 tickets. Okay. So how many tickets do we want to do? Or do you have an equation you want to give me? I'm a little lost. Give me a little bit more what you're thinking. That's all you had. Okay. Say it again. 10 plus 1 times 1,000. Like that? Okay. So $10 is the setting up fee. It's a $1 for 25 tickets. It's not $1 for 1,000 tickets, though. So I don't know that that's going to work. Okay. Can someone give me a equation for best print? Can someone give me an equation for best print? Where should we start? These are what kind of equations? Supposedly? Linear. So how would I start a linear equation? Y equals. Now, what is not changing? Okay, the fee. So it's $10 plus $1 for every 25 tickets. So what is not changing there? Yeah. Okay. Okay, if we take $1 and divide it by 25, that would be the price for one ticket, right? So $1 for 25, and then how many tickets do we want to try? So this is the cost for one ticket. This is the cost for one ticket. Come on, put on your thinking caps. Should we try like 10 tickets? Let's just try what they're talking about here. Here they mentioned, does it matter if they sell 10? Does it matter if they sell 1,000? So let's put in 10 and see what we get. So when I solve this, I get y equals 10 plus 10/25. Okay, 10/25, I can divide by 5/5, and I get 2/5. So this is $10, bless you, and this is 2/5 of the dollar. So y is equal to $10. What is 2/5 of a dollar? 40 cents. So for 10 tickets, for best print, it is going to cost $10.40. Okay? Now, let's try that for SurePrint. SurePrint cost $2 for 25 tickets. So that would be y equals, do I have a setup fee? No, it would be 0. Plus, it's $2 for every 25 tickets. And we want to take it for 10 tickets. Okay. So that gives me y is equal to 20 over 25. Divide by 5/5, and I get 4/5. What is 4/5 of a dollar? 80 cents. So for 10 tickets, which one is going to be the better price for us? Yeah, SurePrint. This is for 10 tickets. 10 tickets. SurePrint is going to win. Okay? This is best print. All right, now let's try it for 1,000 tickets. 1,000 tickets. So y equals 0 plus 2 over 25 times 1,000. Because we don't know how many tickets we're selling, right? And this is going to be y equals the $10 setup fee plus it's $1 for 25 tickets, and we're putting in 1,000. So y equals, that's going to be 0. Oh, I don't know. How many 25s go into 1,000? 4 go into 100. Is it 40? What's 1,000 divided by 25? Or 2 over 25 times 1,000? That's what I thought. 40 times 2 is going to be $80. So over here, it's going to be $10 plus, we said 1,000 divided by 25 is 40 times the 1 So if we're talking 1,000 tickets, then it looks like, this is 1,000 tickets, it looks like best price is going to be cheaper, right? So it kind of does depend on how many tickets we need. Is everybody with me on that? Somebody at the door? Do we want to let them in? Maybe. Good morning. All right. So that's if we have 10 tickets. The second one is if we have 1,000 tickets. The question also says, for how many tickets would we have if they both cost exactly the same? How do I find that? Where are they going to cost exactly the same? How would I find that? Elimination. So you're saying we have to solve, right? Okay. Let's see. Or substitution. So let's go with, let me do this a little bit darker. So let's go with, we're on page 35. Best Buy tickets, we said, was Y equals 2/25 times X, where X is the number of tickets. Okay? That's Best Buy. It was $2 for 25 tickets. No, wait, was that the right one? That was SurePrint, wasn't it? This is SurePrint. All right, then Best Buy is Y equals $10 plus 1/25 times X. All right. Here's what I don't like when we have equations. We have fractions in them. What could I do to eliminate the fractions in both of these equations? We could do that. We could do that. Or couldn't I also just multiply everything in there by 25? Were you saying that? Yes, very good. So multiply everything by 25. Whenever you have a fraction, you always want to try to multiply by your least common multiple. So that gives me 25y equals, this 25 is going to cancel out with that, 2x. And for Best Buy, that's going to give me 25y equals 250 plus 1x. Okay, now how do we want to solve these? Should we graph? We don't have any graphs on here. What could we do? Elimination. Which one do we want to eliminate? Let's get rid of the y's. So before I can just eliminate them, what do I need to do? Divide by, we've got 25y, we've got 25y here. We could get rid of them, but I have to change one to be an opposite. So I would need to multiply by, or divide by. How do I get one of these to be opposites? Yeah, multiply by a negative. Let's multiply the top one by -1 because there's less to multiply. So I get negative 25y equals negative 2x. So these are going to cancel out. Now remember, we don't have anything else on that left-hand side, so I've got to put 0 there. Equals, okay, when I add them, I get 250 plus, or actually minus, because 1x and 2x together make negative x. So let's add x over here. And so x is equal to 250. 250. Really? That doesn't go any more down? So what does x represent again? Number of pink tutus? What are we talking about? What is my x? Number of tickets. So that means the number of tickets. When I get 250 tickets, how much is that going to cost us for each of them? Well, substitute that in. Let's see. Let's do it for y equals 2 over 25 times x, which is now 250. So 250 over 25 is going to be 10. 10 times 2 is 20. So when we reach, I have out of space, 250 tickets, it's going to cost $20 for both amounts. Okay, so that would be where they would intersect. All right. So what does that tell me? Which printing company do I want to go with? I can't even get that all on the same page. Do I want to go with SurePrint or BestPrint? We said for 10 tickets, we wanted to go with SurePrint because that was 80 cents. And it cost $10.40 with BestPrint. When we did 1,000 tickets, we said we want to go with Best Price because that was $50 as opposed to $80. And we just found out when we do 250 tickets, it's going to cost $20. It'll be the same for both of them. So which company do we want to go with? Remember, you're supposed to be presenting this to your friend. What are you going to tell her? Math is not her strong suit. You're like, oh, mine neither. No.
Maybe BestPrint.
Why BestPrint?
The price decreases as the number of tickets
The price decreases as the number of tickets decrease.
increases.
The price decreases as the number of tickets decreases? I don't know about that.
Increase. The number of tickets increases. So as you buy more tickets, the price goes down.
Okay, but if they cost the same at 250 tickets, what do I need to tell my friend? They're the same at that price. What about if we don't get 250 tickets? What if I got 249 tickets? Which is going to be the best price? SurePrint. What if I get 251 tickets? What's going to be the best price? BestPrint. So we need to tell my friend, look, how many tickets are you going to sell? Maybe you don't know. If it is anywhere between 1 and 249, you need to go with SurePrint. If it's going to be 251 up to 1,000 or however many more, then you need to go with BestPrint. Okay? So the answer where they are the same, it's the same cost. If it's fewer tickets, it's SurePrint. More tickets, BestPrint. Okay? Does that make sense? All right. Now, let's go to another one. This one, everybody, you really should pay attention because lots of students have difficulty with this. This is on page 36. We're talking about dimes and quarters problem. The only coins that Alexis has are dimes and quarters. You guys even touch change anymore? Hardly. Do you? Okay. Okay. Her coins have a total value of $5.80. She has a total of 40 coins. How many does she have of each coin? That is a good question, Miss Dee. So we need to come up with two equations. Two equations dealing with dimes and quarters. Okay, let's work together as a team. See if we can get this done before the bell rings. We got about 10 minutes. So talk to me, talk out loud. What's one thing that they tell us in the information? Total value. What does that look like if I say I have a total value of $5.80? What, if I was going to write something down, what would you write down? Equals, right? Total value, and what would you write? $5.80. Okay, hey, that's the start. We have a total value. Total implies what operation? People, please. Addition, yes. Okay, now notice this says value. What are we dealing with? Money. What kind of money? Okay, more specifically, dimes and quarters. Do we have value in dimes and quarters? 10 cents. And quarters are going to be 25 cents. Make sure, because you have a decimal point here, you have to include decimal points here. If you didn't, it would be $10, right? So I need to show something for dimes, and I need to show something for quarters. Do we know how many dimes she had? How could I represent the value of some unknown number of dimes? Okay, but specifically, what expression could I use for dimes? You're right, X, but I have to say, yes, I have to say 0.10X because it's 10 cents for however many dimes I have, right? Okay, and what about my quarters? Do I know how many quarters she has? So how am I representing that? X? Y. X or Y? Do they have to be exactly the same as the number of dimes? No. So should we use X or should we use Y? Yes, very good. All right, so we've got our value. The key word there is value. So one of your equations is value. What else do we know in this problem? That's that word again, total of 40 coins. How would I write something a total of 40 coins? Equals 40. Equals 40. Now, when we're talking about 40, what is that talking about? Is that value? Okay, amount of coins. Okay. Do we know how many dimes she has? Do we know how many dimes she had from the top part? Did we represent it somehow? What was it? I can't hear you. Well, that's value. 0.10 times X gave me value. How many coins is there in that 0.10 times X value? X. So couldn't I say this is X number of dimes, right? We know it's X number. And it says total, so I'm going to put plus here. How many quarters do I have? Why? Because I'm asking. Yes, why? Oh, so you have X number of dimes plus Y number of quarters. That equals 40. And then if you have 0.10 times X plus 0.25 times Y, that gives me the value. All right, so now we have two equations. These are linear. How would I solve? What would you do here? What would you do? Elimination, okay. Which ones do you want to eliminate, the X's or the Y's? All right, let's get rid of the X's. Elimination. So we're eliminating the X's. How or what do I need to do to eliminate my X? She says, let's multiply by negative 0.10. What do you guys think of that? Negative 0.10. Okay, so that gives me a new equation, which is negative 0.10 times X minus 0.10Y equals negative 40 times that is going to be what, 4.00? And I'm just going to rewrite this one. Rewrite 0.10x plus, if I could just get that to write steadily, that'd be fantastic. 0.25y equals $5.80. Oh my gosh, twice in the same equation. $5.80. So add these together. These cancel out, which is what I wanted. What is 0.25y minus 0.10y? 0.15y equals, what's negative $4 plus $5.80? $1.80. I am solving for y. Divide by 1500s, 0.15, both sides. Y is equal to, geez, I don't know. Gosh, that's not even going to come out, is it? Maybe it will. Who's got it? Please, somebody take $1.80, divide by 15 cents. What do we get? 12. So 12. Y is my number of quarters. So I'm going to have 12 quarters. And if the total number of coins I have is 40, that means I would have 40 minus 12, which is 28 dimes. How could I check that answer and see if that works for the other one? Substitute in. So if I have 12 quarters, 12 times 25 cents is what, 4? 3, thank you. And 28 times 10 cents would be 280. 3 plus 280 is 580. Woohoo! We got it. So we had 12 quarters and 28 dimes. We just finished in the nick of time. So both of these problems were a little meatier, right? Okay. Keep hold of those. Please remember, homework 1 due today in Canvas. Homework 2, you can start working on that. That is due on Tuesday of next week. Okay? All right. Great job there on that last problem. All coming together. I love it. All right.